Hello, my name is Gerritt Bakker, and the topic I chose for my final project is Building Information Modeling, a knowledge management technology for the AEC industry. The company I work for is part of the AEC Industry, which stands for Architecture, Engineering, and Construction. There's a lot of different companies and disciplines involved in a project, which is what makes it highly collaborative. Because of this, there's a huge knowledge management tools need. Just because the scale of the projects often require very high levels of coordination. Also, construction documents need to be created and submitted to the city whenever working on a new building design. Building information modeling is a process and technology that lets AEC professionals design buildings using 3D digital models. It's considered a vast improvement on the drafting and CAD workflow. Models contain specific designs and support the creation of those construction documents. Also, each discipline constructs their own model containing their own design. Usually, this will start out with the architect creating the rooms and the walls and the skeleton of the building, and then they'll send that model out to the electrical engineer and the mechanical engineer and the structural engineer for them to design their systems. And then later on, all of those models are combined and overlaid to represent the finished building. By far the standard BIM software is Autodesk Revit. It's used by every discipline, and it supports the creation of both two-dimensional and three-dimensional drawings. Autodesk Navisworks is a supplemental program that is used in conjunction with Revit that enables 3D clash detection. So when all those models are combined near the end of the project, they're in a lot of situations, since they were designed separately, there are some significant overlaps. And once these clashes are found, then the disciplines can coordinate together to solve the issue. It can also be used to conduct virtual walkthroughs of the building. So if you want to show the client what their building is going to look like when it's finished, you can do that from your computer. BIM objects are detailed 3D geometric shapes or objects that are used to represent a product. So inside the building, you can place furniture or mechanical, electrical, and plumbing components, or even landscaping elements like existing trees or hills even. And each one of these BIM objects contains metadata that displays the product, information, and the installation specifications. So that can be, if it's a chair, it'll show how big the chair is or how tall the chair is and what the materials it's made out of. And what's great about these objects is they can be itemized and represented in a table and exported into a spreadsheet. And that can just be a good way for people to look at what objects are going to be in the building. So here's an example of the Autodesk Revit user interface over here on the right. This is the 3D representation of the entire building. And as you can see here, you have tools on the ribbon that let you make walls or doors, components and columns, and then information related to those objects. So how tall the wall is going to be, what type of wall it is. And then down here in this view, you can select other views to see. So if you only wanted to see one specific room, you could set this up to take you to look at one room. This box here shows the furniture. This is what the objects look like. They're very detailed. It even has color in here, but attached to this object, you're going to see what kind of material that's made out of, or the material of the tabletop, as well as the dimensions. And here, looks like a MEP system that was laid out. You can see how everything kind of fits together in this system at the bottom, all in 3-dimensional. And then in the image of Autodesk Navisworks, the clash detection software, you see that the person using the software puts the structural model and the MEP model together to see if there are any clashes. And it looks like here they discovered one. This is the green, looks like it's a structural beam. And then the red looks like it's an air duct of sorts. So when they run this, they see that there's a problem here. And of course, when this gets out in the field, they can't construct a structural beam going right through the air duct. So they'll have to coordinate, see who needs to move what. A bit of a new technology in the BIM world is the ability to manage models and documents in the cloud. And this is done through the BIM 360 document management system. The models can be stored and linked together in the cloud. And what's neat about this, in the past, anytime a discipline updated a model, they would have to save a copy of it and then send it out via email or another repository system. And sometimes changes could happen quickly and often. So anytime you were looking at another discipline's model, it was usually behind and it didn't have all of the information that it does or it should. So the benefit of working in the cloud is whenever a discipline saves a model or makes a change, it's updated immediately and the change is reflected. It's also a web-based repository system for multiple file formats, and that includes PDF or images. Sometimes workers in the field will take pictures of the existing conditions and upload that so people know what they're working with for the design. And BIM 360 supports the creation of project teams. You can have users assigned to specific projects so only they can see the information related. And there's also automated email capabilities. So if you were to change something in a model, you could set it to notify another team member that a change has been made and they need to be aware of it. And this is an example of Autodesk BIM 360. This is what the interface looks like on the web browser. So over here, we have the design folder and the architectural folder selected. So these are the architectural models. These look like the model files, and this one looks like it's a PDF of a sheet or construction document that'll be submitted to the city. And then there are identical folders here for different disciplines. So you would see similar files like this in the civil folder and the electrical folder. It's important to know that a successful BIM implementation plan requires a lot of planning. And also, not having BIM limits your project involvement and availability. BIM users can work in 2D. So if your BIM users can typically work with companies that have not adopted BIM and still work in CAD, but it does not work vice versa. So if you're a company that does not use BIM, the odds of you landing a job that is primarily being done in BIM is very low. There are very high upfront costs expected between the software and the employee training. It's typically better to train your CAD users to use BIM or learn BIM than it is to hire BIM experts, because as it is, there's a very low quantity of BIM experts. Also, BIM isn't right for every organization or every company. Some smaller companies that thrive off of residential projects or very small scale projects, maybe family-owned businesses, typically won't need all of the capabilities that BIM has to offer and would be better off not making the transition. Also, it's important to know that when adopting BIM in your organization, it's not instant. There are BIM maturity levels that are a way to measure the level of detail and collaboration present in the model. This is a good way to kind of start small and build up to higher levels of BIM integration. It starts at level 0, which is essentially using the BIM software, but for only 2D purposes. So it looks a lot like CAD drawings, and there's no coordination or collaboration with other disciplines. After that, it moves up to level 1, which is partial collaboration, and it's a mixture of 2D and 3D drawings. Level 2 is full collaboration between all disciplines, and it introduces 4D and 5D document sharing, which is PDF files and images. And level 3 is the highest level of the BIM maturity, which represents full integration. And typically that means there is one core model with all of the disciplines are linked into, and it's the highest level of collaboration between disciplines. There are numerous advantages of BIM. BIM encourages collaboration at all phases of a project, and the clash detection allows designers the chance to catch mistakes before they become a problem during construction. And this is a big deal because there's a lot of additional costs that come into redesigning a project. Sometimes they'll get all the way out into the field and the building is halfway constructed and they realize that there's a huge design flaw. In this case, everything is stopped and it's the process has started over. They have to send documents back and forth, and the construction team is no longer working and on the construction of the building. It slows things down and there's a lot of extra costs. There's the benefit of metadata being in the objects. They can be exported into the spreadsheets to show every piece of furniture in the building or every piece of structural column in the building, and that can be used to provide pricing information. BIM has proven to reduce the cost and the project lifecycle duration while also producing very high quality results. And another advantage is that the BIM model can be used even after construction. A lot of the times it will change hands and go to the owner of the building, in which they can use that for facility management. So they can keep tabs on the objects in the buildings or the building or the components and tell how old a component is and to have a clue on when it needs to be replaced. There's not a lot of disadvantages of BIM. Probably the biggest thing is the high upfront implementation costs. The software alone is $2,545 per year for every user that you have. So if you have a department of 4 people all using BIM software, it's going to be $10,000 a year. Also, the training and salary expectations are usually quite expensive. And like I mentioned before, BIM is not for all organizations. Large-scale projects, large buildings benefit much more than small standalone projects. In conclusion, BIM is a very valuable design and collaboration tool used in the AEC industry. It lowers cost, reduces risk, and improves the overall quality of work. It's growing very quickly, and eventually it will replace CAD in most organizations. Thank you very much.